Hey you guys, welcome back to the channel. It's been ages since I made my last video. I was busy with work and the corona and everything. So here we are back with the analog joystick. As you remember in my last video I told you that the ESP has only one input of analog, which is a problem since we have this movement, and this roller as an analog. So I had to find a solution, and the solution will be some form of a multiplexer. I got three of them here. I got the CD74HC4067, which is a 16 channel. I got the CD4051BE, which is an 8 channel. And I got the good old CH3008, which I've used in previous project, but I want to try something else today. So let's see datasheets, understand how they work, get it all looked up, and test it out.
I never used this chip before, so I had to pull his datasheet. Let's take a look. We're looking now at the function diagram. And as I mentioned before, it's an 8-channel analog multiplexer. And we got here channel 0 through channel 7. Those are the inputs for the chip. Now we got A, B, and C. Those are digital input pins that you can set either low or high. And together with this truth table, we'll decide which of the 8 channels will connect to the output that this goes to your microcontroller. So let's say if we want to choose channel 0, we have to keep A, B, and C at low. If we want to choose channel 7, we have to put A, B, and C at a high, so we get 1, 1, and 1. So now let's go see how the chip itself looks like. So now let's look at the pinout. As you can see, the channels are 0, 1, 2, 3, 4, 6, 7, and 5. This is the common out. This is where we're going to go to the out. We got VDD. We'll have to check out what its tolerance in a second. We got VE. That's for negative. We're not going to have any negatives. So we're going to connect this to ground. VSS goes to ground as well. We got the A, B, and C. And the only one we haven't talked it is the INH. If this is set to low, the truth table will take its value from A, B, and C. If this one is set to high, it cancels this and cancels all the channels. And I will show it to you later on. So now let's take a breadboard. I'm going to connect it first to an Uno and run some tests before I connect it into the big setup. Last thing I had to do just a second before connecting it to a breadboard was to check the supply voltage to make sure that the 5 volt and the 3.3 of the ESP is within the range, and it's okay since the max is a 20 volt and the minimum is a minus 0.5. So now, yes, let's go to a breadboard.
So we got wired up. We got the IC here. We got A, B, and C connected through 7, 6, and 5. We got the INH, which is the one that disable or enable all the channels, connected to number 4. We got a potentiometer connected to the channel 0, and of course ground and VCC. So now let's write a simple software that will set the chip to connect to channel 0, and we try to read it through the output that's connected to analog 0.
I wrote the following very simple code. I defined a pin for C, B, and A in the INH, the analog pin A, started the serial, set all the pins as output and set them to low. Remember we talked about the truth table? And then all I did was to read the analog value of A0 and print it out. And now if I open the serial monitor, you can see the read, and I'm now just moving the potentiometer. I can get all the way to here and then all the way back to here. Brilliant. So now what I'm going to do is I'm going to connect A, B, C in the end, the INH, into ground. So I want to have to set them a pin on the ESP and then connect the analog from the stick and the output from the chip to the ESP and see if I get the same result. If I do, I'm going to find the pinout for all the A, B, C, and INH, and I'm going to connect the other 2 analogs. So let's try it out.
So I've made a change, and now it's connected to the ESP. Joystick is here, and here is the screen, and you can see now that I can control the screen still with a joystick. And it's connected through the multiplexer. So the next step will be to connect this to the multiplexer instead of this one here. Let's go do it.
When adding a big feature into a program, I always prefer to build that outside in a separate program. So I've done the same here. So what I did is defining the digital pins for each of the truth table pins, the A, B, and C. I defined the pin for the INH as well. I've placed all the pins for the truth table into a truth table pins array, and I will show in a second how useful it is. And then what I did is the same as I did with the Uno example, put this in output and low, and the same I did for all the truth table pins, put them as an output and then put them in low. What I did in the loop, it's pretty simple. I'm looping over the first 3 analog channels, and I get the value from get analog position, which we'll cover in a second, into the channel analog position and print it out. In order to know which of the A, B, and C pins to switch high or low, I loop over the 3 of them, this is the truth table pins, and I get the bit that in that position of the byte, meaning basically the truth table is the first 3 bits of the byte that is the channel number, and I'm getting it with the bit read, and I'm just getting the analog value and returning it with doing some math that is related to what resistors are connected on the voltage divider, which I covered in previous episode.
So now, as you can see, there's a change in channel 1, channel 0, and channel 2. And yes, the numbers on channel 2 are much higher, and that's for the reason that I'm missing 3100K ohm resistors, and I'm under house quarantine, so I can't even get one. But I don't need them for right now for the game, so it's okay, and I can use those values as well. So next step is to put that into the game. And now, as you can see, I can control both of the directions with the joystick. So this is how the setup looks like right now. On this side we got the Node MCU, we got this section which is the buttons with the logic level converter in here, and this section is the analog with the CD4051. I think one of the most important things I need to do next is to solder these 2 sections, leaving wires going on both sides because I'm not sure about which board I'm using, and I probably want something that is a different breakout that I can actually solder. This is really nice for experiment, but it's not really good for having it in a case. I did mention another chip earlier, but this one fitted so well, so I'm not even trying this one because it's also 16 channels while this is only 8, and I really only need 3. So I guess another project. If you want to know about the CP3008, I got another video. I'll leave a link on the screen and in the description.
Now that the hardware part is done, I want a better game that fits the joystick. The demo was a great start, but it's time to create something new. If you have any ideas or want to help out, let me know in the comments. Hope you enjoyed the video. If you haven't done it by now, please subscribe, give a thumbs up or leave a comment. And see you next time.